we're moving on. We want to find the enthalpy of neutralization, okay? So that's just the heat of neutralization, joules per gram of sodium hydroxide. Okay, so here's my heat gained from that neutralization process. It was gained. Now I want to take that amount of heat and divide it, since that heat was coming from the sodium, well, I want to divide it by the mass of the sodium hydroxide. And so take this heat divided by the mass of sodium hydroxide that I used, which from that solution, it was the difference between those two, which was 1.8513. Okay, so that's joules per gram of sodium hydroxide, 1580 at 3 significant figures. Okay. Alright, now it is complaining about that, so let's see, what did I do incorrectly here? Okay, and there it is. Note the sign. Heat is given off during the neutralization. Okay, so we're looking at this from the perspective of the sodium hydroxide, as opposed to the solution itself. Okay, so this is going to be a negative value. Okay, and there we go. That was accepted this time. Now we want the heat of neutralization in joules per mole. So here's the heat of neutralization in joules per gram. Now let's find that in joules per mole. So we just use the molar mass of the sodium hydroxide, which is 39.997, and I'm going to take that joules per gram and per gram, so I'm multiplying it by grams per mole to get the joules per mole of sodium hydroxide. And again, that's going to be negative 63,300. Okay, so negative 63,300, and that is my okay, once it takes that, that is the heat of neutralization in joules per mole. Okay, so a lot of these are just conversions, and it's all about looking at those units, and it may help to write them out as clearly as possible. All right, so now we're in the last section. Heat, or rather the mass of the HCl solution. Again, just the difference between those. That's the one that I attempted to put in the first time. It's the difference between these two, which is 60.2193. Okay? And now I want the mass of added sodium hydroxide. Again, another difference just between these two. Alright, so here are those two. I'm going to subtract them. 2.1493. Okay, now we want the mass of the neutralized solution. So that's the mass of the whole solution, the HCl solution as well as the sodium hydroxide. So we add those two together. The HCl solution and the sodium hydroxide, and there you go. Okay, 62.3686 grams. All right. The change in temperature of the solution, again, taking a difference between our temperatures, the maximum temperature reached from the initial temperature of the HCl solution. So that'll be 13, if I subtract 22, that'll be 13.4. And then I want the heat released, so that's going to be negative in kilojoules by the reaction of those two. Okay, so I'll put the negative to remind myself, and it's in kilojoules, the heat released. All right, so heat, I'm thinking Q equals mc delta T, and it is released by that reaction. So I'm talking about the combination there. So I have the mass of the solution times the specific heat of the solution, which we're approximating as the same for water, times the change in temperature, which we said was 13.4. Okay, so I have 3496, or if I round that to three significant figures, it'll be 3500. Okay, however, that value is in joules, right? From up here, joules per gram, the grams cancel per degree Celsius, my temperature cancels. I have joules, so I need that to be 3.50. Okay? And that is my kilojoules per mole. Not per mole, but my kilojoules of heat released. Okay?